Hello, greetings to you, my dear students. Today we are going to see one very interesting topic, my dear students. Yes, already we have seen what is graphical transformations, my dear students, graph transformations, and this is the second lecture video, my dear students. So I hope already you have watched the first lecture. If you haven't watched that lecture, please go and watch that lecture, my dear students. You will learn a lot why we need graph, how to draw the graph, and what are the things we learn from the graph. Those things in depth I have explained you, my dear students. Once if you have seen that video, you never ever have any doubt in graphical transformations, my dear students. Now in this second part of the lecture, already in first part I have shown you why we need graph, what are the functions are there. In functions, in first video I have explained these are the functions we are going to cover, my dear students, how to draw a graph and what are the things are there, everything in depth we are going to see, my dear students. In algebraic we started with polynomial functions, my dear students. In polynomial I started with linear function. For your understanding, that is identity function, my dear students. For that itself I have taken nearly half an hour lecture. So see, only for identity function to find the domain, range, everything, it took me half an hour to explain in depth, my dear students. So I hope you have watched that video. In this lecture, I am going to explain you y is equals to x square, my dear students. In this lecture, I am going to explain you x square polynomial. This function alone, my dear students. Only I am going to explain you x square function. Let's see for this session alone how many minutes it will take to explain entire x square function. Okay, my dear students. Let's go into the topic, my dear students. So these things already I have explained to you, my dear students. What is identity function, domain, range, symmetric, everything I have explained to you. If you have any doubt, please go and watch that lecture. And I have explained to you what is the trick to find one-to-one function, a one-to-one function which is also called as the injective function. Everything I have explained to you, my dear students, how to find the one-to-one function through graph. Once I have drawn the graph means whether that function is one-to-one or not. How to find, my dear students, everything I have explained. Same trick for onto function also I have explained you, my dear students. Don't worry, in this lecture again I will explain you for x square how it happened. Okay, so these are the things in last class, my dear students. In first lecture we have seen. Now let's go into the topic, our original topic, x square, my dear students. So the graph of f of x is equals to x square. That's what we are going to see now, my dear students. So before that, plotting a graph is very simple thing, my dear students. Just you have to mark it rough diagram. That rough graph is enough, my dear students, to know lot. That gives us so many informations, as I said before, domain, range, symmetric, periodic, even or odd function, differentiable function, continuous function, discontinuous function. So many things we learn only from this graph, my dear students. Such an important thing, this graph. So when I'm going to plot a graph, 0, 1, 2, 3, 4, -1, -2, -3, -4. So here 1, 2, 3, 4. Let me take black. So my dear students, now our function is x square. Already I hope you all know what is function, sets and relations topic. Already we have seen what is function. So here the given function is x square, my dear students. So whatever number I have, it will just square that number and it will give me the output as 1, 4, 9. Like that it goes, my dear students. Whatever number I have, just the duty of the square function is it have to square that number. That's it, my dear students. In the same way, just we will map. Likewise, now we are going to plot this function, my dear students. So 0, which means 0 alone, my dear students. So for 1, I am going to take 1, as well as for -1 the whole square, again I am going to take 1. So there are 2 points, my dear students. Again for 2, I will take 4. Say again for -2, it is going to be 4. Just 4 values enough, my dear students. If you connect these points now, you will find the parabola, the upward parabola, the upward direction parabola. We got it, my dear students. This is the x square function, my dear students. Graph of x square polynomial. Now, just now we have drawn the graph, my dear students. Now what we are going to see? Now we are going to do research. What are the research? These are the research values, my dear students. We are going to find what is the domain, what is the range, symmetric, everything. In detail, we will see in this video, my dear students. So, now we have to find the domain. Is there any values are restricted for x square, my dear students? Whatever value I am going to give, it is going to give me. There is no issues, right? If I am going to give -1 of the whole square, it is going to give me 1. Even if I take 100, -1000, any values, it is going to give me the value. For any of the value is not restricted, because which is not undefined like that. For every domain value, which means for every -infinity to +infinity, it is going to give me one defined value in R. So for me, no problem, my dear students. The domain is R, which means -infinity to +infinite. This is the answer, my dear students. I hope you understood it. If you have any doubt, please don't hesitate to ask me, my dear students. I am always here to help you. Okay, for you only I am doing everything. If you find it useful, please comment it down, and if you have any doubt also, please comment it down, my dear students. Okay, then range, my dear students. What is range? Usually what is range, my dear students? In function, in domain and codomain, what are the values are mapped, that only we call it as range. So what the domain, I can take any values, but what are the values it will give, that is the range, my dear students. So here from the graph you can see, my dear students, this graph is going like this. It never takes any negative values, because it is the square function. Even if I apply -1, it gives me +1, -2, +4. So for everything which gives me only positive numbers, my dear students, not even a negative, not even a single negative value I am getting. Every values are positive, so the range is R plus. But here you have to make one point, my dear students, which is that 0. 0 is not included in positive real numbers. Why, sir? Because 0 is neither a positive integer nor a negative integer, which is that neutral in center, my dear students. So now, but 0 is there in my function. 0 is there in my domain as well as range. So what I have to do? I have to include that using the union symbol, and which is the set. I hope these notations and all you know, my dear students. So no problem, it's a R plus union 0. 0 alone I needed, nothing else, my dear students. Only I have to include 0. Other than all the R plus, everything there will be the point, my dear students. For me, no problem at all. So I hope you understood what is the range. In range, be careful, my dear students. Sometimes they will confuse you. You have to be very careful. Okay. Then, my dear students, it's symmetric. Symmetric about what, my dear students? In last class, I have explained you in identity function. The graph goes like this, which means if I take the cut in origin, it is symmetric about opposite quadrants, which means 1/3. Likewise, it had. Here how it, my dear students, if I cut the graph at middle, which is like half here, they both are symmetric, as I said before, like our face. So here the graph goes like this, my dear students. So what is the answer? Symmetric about y-axis. In y-axis it is symmetric, my dear students. You can't say it's opposite quadrants, because it is both are going to be the same. We can't say that quadrants, so it is y-axis. Y-axis only cuts the origin, and it is going to be similar on both sides, like this, my dear students. Since it is a 2D image, 2D pictures, I can't show you that much visually. Very soon I learned that animation, my dear students, and I will show you the 3D animation picture, how it cuts and how it goes, everything you will see, my dear students. So now it is symmetric about y axis. Okay, my dear students. Now next thing we have to find whether it is even or odd function. What is even, what is odd function? Already I have explained to you, my dear students. If f of minus x is equals to f of x, then that function is called as even function. If f of minus x is equals to minus f of x, then that function is called as an odd function. Now let's see, my dear students, our f of x is x square. Now I have to apply f of minus x, so that again I am going to get the same value, my dear students, x square. So since f of x and f of minus x, they both are equal, this function is an even function, my dear students. Already in last lecture I have said through graph how we can find whether it is the even or odd function. If the graph shares that image, his image, with any negative quadrants, then that function will be an odd function. If it won't share anything in negative quadrants, I am the completely positive guy, I won't be any kind of negative values. If the graph is like that, means then that graph is completely the positive only, my dear students. So it is an even function. I hope you understood. Whenever the graph goes only in the upward direction, in the positive direction, in r plus values, then that function is an even function, my dear students. If it is odd function, then it also covers the entire thing. It won't leave anything, my dear students. It always takes the negative quadrants as well as the positive quadrants. By that we can find in next. There are so many standard graphs are there, my dear students. In standard graphs itself, we can see all the examples step by step. Okay, my dear students. In next lecture, we have the example for that. Let me show you. Then, so it is the even function, my dear students. It is not a odd function. So whether it is periodic or not, my dear students. In last lecture, I have explained what is periodic. Periodic function, which means after certain period, if the graph, it have to again take the same value what is the first value it have taken. But here, is it possible, my dear students? For 0, it is 0. Again for which value, which number, it will give 0? It won't give. So if it is not giving like that, means then this function is the non-periodic function, which is not a periodic, my dear students. Mostly the periodic condition comes in piecewise functions, as well as in trigonometric so many functions are there. But in polynomial, very less functions are there, my dear students, periodic. Most of them are not. So these conditions they might ask, my dear students, whether the polynomial functions are periodic or not. Like that they will ask you in your exam, so be careful. Okay. Then, my dear students, this is periodic function, is not. Then we have to find one-to-one function or not. So in last lecture, through graph how to find one-to-one function, I have explained to you, my dear students. So it's not a big deal. Actually, the one-to-one function means whenever I draws the line, it have to cut it in single line. Make sure, my dear students, it have to cut it in single time. If it cuts 2 times, then this is not a one-to-one function. That's what the definition also says, right, my dear students. In last lecture, I have explained you in detail. If you want, please watch that lecture, my dear students. I have added the timestamp, so you can directly go into that. So one-to-one function, which means what, my dear students? If x1 is equals to x2, then f of x1 is also equals to f of x2. If f of x1 not equal to x2, then f of x1 not equals to f of x2, which means that is a one-to-one function. But here x1 and x2 are not equal, but their functional values, their output values are equal. Since they are equal, only it is not a one-to-one function, my dear students. At any cost, it is not a one-to-one function. Okay. So I hope you understood it, my dear students. That's how they have derived this generalized term. If you draw any line and if it cuts at 2 lines or more than one, means also that is not a one-to-one function, my dear students. Now let's see the onto function, my dear students. The onto function, what is the definition of onto function, my dear students? Y is equals to x. which means it have to cover the all the values in the codomain, which means it have to be equals to range. Every values in the codomain have to be mapped. That's what it means, my dear students. Here in graph, in last lecture I said, if you draw the line anywhere, it have to touch at least at one point. For me, it's no problem, my dear students, whether it touches to more than one, more than two, that and all doesn't matter, my dear students. For me, the only thing matters, which is it have to touch all the graph. Wherever I draw the line, it have to touch. But here, my dear students, you can see my graph is at only at R plus, it is not in R negative, which means for R, generally I take domain and codomain as R. For R, this function, this x square function, which is not an onto function. For R, my dear students, observe clearly, for R, not onto. But here, codomain is in our control, my dear students. You have to think. Maybe in place of R means, here if I draw any line which is not cutting, so this function is not an onto function. But keep in mind, my dear students, if I have take R plus union 0, actually this range value, if I have taken the codomain only what I exactly needed, if I have taken like this, then this function is an onto function, my dear students. I hope you understood it well. Because whatever values is there, it is going to cut everywhere here. Here for me, no problem whether it takes 2 values, 3 values, 4 values, but it have to cut. It have to touch all the lines in the graph, in the entire graph. In the codomain, what we have arranged. If I have taken the entire R means, half of the R is not there. So what I'll say, let me take the another half. If I take only this half, the answer is right, my dear students. But for the entire graph, half of the values are not there. So it is not onto. But for R plus union 0, this is going to, even if you simply take R plus, which is not an onto function, my dear students, R plus union 0, which means this is an onto function. So onto function, they will confuse you with codomain, my dear students. Codomain matters a lot. It is the, for onto function, for one-to-one also it's going to be easy. For onto function, this codomain range is matters a lot, my dear students. I hope you understood it well. If you have any kind of single doubt, please ask me in the comment section. Okay. So this function onto based on the codomain, for R, it is not a onto function, my dear students, but for the redefined codomain, which means positive numbers, positive real numbers with 0, that function is have the range. Okay, so it is the onto function. Bijective function, whether it is bijective or not, even onto have may or may not be possible, my dear students. For one-to-one, strictly it is not a one-to-one function at any cost, because it violates the basic rule. The basic rule, at any time basic rule matters a lot, my dear students. Whatever special case you study, you never collapse any of your ideas with the basic formulas, because basic formulas matters a lot. Okay. Okay, my dear students. So this function is not bijective, whether it is onto or not. Surely it is not one to one. In that case, I have the strong thing, which is that this is not a bijective function. Okay, my dear students. Whether this function increasing or decreasing. So for this, you can see, my dear students, for this function, we can't say this one is the strictly increasing function, strictly decreasing function. Like that we can't say, my dear students, because some values are decreasing and some interval it is increasing. So based on the interval, it differs, my dear students. So this function is like increasing as well as decreasing. Based on the interval only we can say. For the function generalized concept, it's not there, my dear students. If the function is only like this means, we can say it's increasing. If it is only decreasing means, we can say that one we call it as monotonically increasing, single side, monotonically decreasing. But here both of the possibilities are there, my dear students. So we can't say that point here. Now derivative, my dear students. What is derivative? Differentiation function, as I said before, the differentiation, continuous, discontinuous functions, these functions are matters a lot. If the graph is smooth as well as continuous, that function is the differentiable function, my dear students. If it have any sharp edges, then it won't be the differentiable function at that particular sharp edge. But it's the continuous function, there is no doubt in that, my dear students. Here it is the differentiable function only. You all know what is the derivative value for x square, which is 2x, my dear students. So if it is derivative, it is also going to be integrative, my dear students. Those things now you no need for graphical transformation. Other than this topic is going to be easy, my dear students. I hope you understood it well. For this itself, I have taken nearly 21 minutes. What to do, my dear students? Your understanding matters a lot for me. So if you have any doubt, please ask me in the comment section. In next lecture, my dear students, I will teach you what is x cube. We'll just like this, we will finish it off. We will take it and we will separate that x cube into several pieces and let's learn everything, my dear students. Okay. So that's what I have mentioned here, my dear students. X square is also called the square function and domain of the square function is R and its range is R plus union 0. That's what I have explained to you, my dear students. Or else you can also use this interval sign, 0 to infinite. 0 is we have taken in square bracket, which means 0 is included here. And clearly, my dear students, y is equal to x square is parabola. There is no doubt in that. And x square is an even function, I said to you, and this graph is symmetrical about y axis. These things also I have explained you before, my dear students. And if it is possible, please buy the book Play with Graphs, my dear students. Sorry. So my dear students, if it is possible, please buy Play with Graphs book, my dear students. That is going to be very, very useful for you. Play with Graphs by Amit Agarwal. Amit Agarwal. His book is so good, my dear students. From that book, you can learn a lot. If it is possible, please buy that book. I will cover most of the graphs with clear method, but his book is also so good for your understanding, my dear students. Whenever you are feeling bored, just like seeing the diagram, just see the graphs, my dear students. You feel so interesting and it is going to be so enjoyable, my dear students. I hope you find this lecture so useful, my dear students. In next lecture, let's discuss what is f of x is equal to x cube. And now, bye bye. Thank you, my dear students.